Okay, so now we will discuss the geometric sequence. Now, a geometric sequence is one in which the ratio of any term to the term that directly precedes it is a constant. This is a little bit different than the arithmetic sequence, where that difference between any term and the preceding term was a constant. So instead of the difference being a constant, we now have that there is a constant ratio. So in this case, we have a constant ratio instead of difference. So what we want to talk about, we first want to find out how to find the nth term. So let's take a look at an example. The first example, we want to write the first 5 terms of the geometric sequence. And this geometric sequence will have first term A1 and common ratio R. So A1, the first term of this sequence is 7. And the common ratio, instead of using D for common difference like we did with arithmetic sequences, we're going to use R for common ratio because we're dealing with a geometric sequence. And the common ratio is 2. So that the first term, A1, is 7. The second term is what you get when you multiply 7 by the common ratio. So it's a product instead of a sum. So 7 times 2 is 14. And then the next term is what you get when you multiply the preceding term, which is 14 by 2. So you get 28. And the following term, you multiply the 28 by 2, the common ratio, and we get 56. And then the fifth term, A5, would be what we get when we multiply the fourth term by 2, so that would be 112. And this sequence would continue on like that. And as you can see, the common ratio, or the fraction that can be created between any 2 consecutive terms, is 2. 14 over 7 is 2. 28 over 14 is 2. 56 over 28 is 2. 112 over 56 is 2. So there is a common ratio as opposed to a common difference. We're not subtracting, we're actually creating fractions, we're dividing. All right, so that is how we would list the first 5 terms of a sequence. So there is actually a formula for the general nth term. So let's talk about the nth term of a geometric sequence. The nth term of a geometric sequence, nth term. So the nth term of a geometric sequence, which we will denote an, the subscript is n, for the nth term. The nth term of this sequence is what you get when you take the first term, and we're going to multiply it by the common ratio, n minus 1 times. So it's a1 times the common ratio to the n minus 1 power. This is the formula for the nth term. All right, so let's answer a question that involves the nth term. All right, so we are going to determine the indicated term. So what we're going to do first is we're going to try to determine the, let's try to determine the 7th term. The 7th term for the geometric sequence with a1 equal to 2 and the common ratio, well actually let's make a1 equal to 5 and the common ratio equal to 2. So what we're going to do is to find the 7th term, where in that case n is 7. Well, that's going to equal a1, which we say is 5 here. a1 times r, well r is the common ratio, 2 raised to the n minus 1 power. Remember, n is a subscript. So n is 7, so that's going to be to the 7 minus 1 power. So what we get is 5 times 2 to the 6th power. All right. So then we do this calculation. Let's see. 2 to the 6th power is 64. So this is really 5 times 64. So the 7th term of a sequence that starts at 5 and multiplies by 2 every time, the 7th term is going to be 5 times 64, which is 320. So the 7th term of this sequence would be 320. All right, so that is how you find the nth term. So this is the formula for the nth term. The other thing that we did with the arithmetic sequence that we're also going to do for the geometric sequence is we're going to look at the nth partial sum. So remember, the nth partial sum is what you get when you add the first term, the second term, all the way up to the nth term. So the nth partial sum. We had a formula for the nth partial sum of an arithmetic sequence. Now we're going to look at the formula for the nth partial sum of a geometric sequence. The nth partial sum of a geometric sequence is different. The formula is a1, the first term, times 1 minus r to the nth power divided by 1 minus r. And this is given that r does not equal 1. So the common ratio can't be 1, otherwise the sequence would not change at all. So we're going to look for the nth partial sums of geometric sequences now. Alright, so let's see. Let's take a look at an example here. Determine the sum of the, let's see, let's determine the sum of the first 9 terms, or let's say 6 terms of the geometric sequence with, let's see, the 6th term of the geometric sequence with a1 equal -3 and r is equal to 4. So a1 is equal to -3 and r is equal to 4. Alright, so here is the formula for the nth partial sum. We're looking for the sum of the first 6 terms, so we're actually looking for S6, the sum of the first 6 terms, which is equal to a1. a1 is -3 times 1 minus r, that's 1 minus r is 4 to the nth power. Remember, n is this subscript, 6. So that's to the 6th power, and that's going to be divided by 1 minus 4. And r is definitely not equal to 1 because r is equal to 4. Alright, let's calculate this. Well, this is -3, and this down here is also -3. We'll get 1 minus 4 to the 6th power. And then 1 minus 4 is -3, so those cancel out. And what we're looking for is 1 minus 4 to the 6th power. That'll be our sum. Let's see what that equals. 1 minus 4 to the 6th power. Well, 4 to the 6th power is 4,096. So this is 1 minus 4,096, or -4,095. So it turns out that the sum of the first 6 terms of this sequence, if you take the first 6 terms, which are -6, -12, -48, all those 6 terms, if you take the sum of those first 6 terms, is going to equal -4,095. Alright, so that's our exploration of the geometric sequence. Next we'll look at the Fibonacci sequence.